Hey math kids, today we're going to look at the angle between two lines. You may remember in a previous chapter that we were looking at the angle between two vectors. And the situation was like this. And this theta had to be in between 0 and 180. Now, the definition of the angle between two lines, we could measure this angle or we could measure this angle. Now, the definition is actually always going to be the acute angle. And so to kind of fix this, in this situation, we had this formula. Now, if we want to get this situation, we just have to add an absolute value right there. And this was equal to cosine theta. So this is the formula that we're going to be using today. And let's see, I'm just going to erase this and then kind of cross this out because now we're only looking at an acute angle. Okay, so it says find the angle between the lines. So L1 is x equals 2 minus 3t, y is equal to negative 1 plus t. And then we have a second line. And then s and t are real numbers. Okay, so we're given these two lines, two-dimensional lines with parametric equations. And so what I'm going to do is first write it in vector notation. For me, it's a little bit easier to understand. So we get 2, negative 1, plus let's do lambda. And then, not lambda. In this case, we'll do t. They both have a t, so we have negative 3 and 1. Okay, second line is xy. It's going to be 1, negative 4, plus s. And that's going to be 2, 3. Okay, now when we have this, it's easy to see that, I'm going to call this B1 and B2 as our vectors. And so our direction vector for the first one is this, and the direction vector for the second one is this. Okay, and so this is B1 and this is B2. I meant we were going to get B1 and B2 from this. Okay, so that's really all we have to use. So we need to find the dot product of these. And so if we're doing the dot product of these two, we're going to do multiply the tops and then multiply the bottoms and then add those. And so we end up with negative 3 on top. And then I need to find the magnitude of each of these. So negative 3 squared plus 1 squared. So that's 9 plus 1. So that's square root of 10 on the bottom. And then if I find the magnitude of B2, it's going to be 2 squared plus 3 squared, square rooted, 4 plus 9. So that's 13. Now let me get rid of some of this. Remember, this is equal to cosine theta. So if I simplify this, I get negative 3 in an absolute value on top, but that's really just a positive 3. So we get 3 on top, and then the square root of 130 is equal to cosine theta. And so we get the inverse cosine of 3 over the square root of 130. go to our calculator. Need to change it to degrees. Okay, we get 74.7. So that's the angle, the acute angle between the two lines. Okay, so it says find the angle between these two lines. So L1 is given as R is equal to 2, -1, 4, plus lambda, -3, 1, -2. And then we're given L2 in Cartesian. Okay. So the direction vector for the first one, this is our B1. That's pretty easy, straightforward to find. Now, what we need to do for each of these is we need to set them equal to lambda. And then solve for x, y, or z. So y is already solved. I'm going to multiply both sides by 2 to get 2 lambda. I'm going to subtract 2 from both sides. So I get -z is equal to 2 lambda minus 2, which gives me z is equal to -2 lambda plus 2. And then similar thinking here, 1 minus x equals 3 lambda minus 1. Negative x equals 3x, or 3 lambda, it's a lambda, minus 1, and then switch the signs, -3 lambda plus 1. Okay, so when I put this in vector notation, I'm going to get x, y, z is equal to all the numbers that are not attached to lambda. So this would be a 0, or wait, let's start with x. X would be a 1, y would be a 0, and z would be a 2. And now all the numbers that are attached to lambda, so -3, 1, and -2. Okay, so our B2 is this direction vector. And then once we have those two direction vectors, we can get rid of everything else. We only care about those. And we're going to start plugging things in to that formula. So we need B1 dot B2, absolute value, over B1, or the magnitude of B1 times the magnitude of B2. And that's equal to cosine theta. Okay, so if we just multiply like terms, so -3 times -3 is 9, 1 times 1 is 1, and -2 times -2 is +4. That's going to be 14. Plug that into the top, absolute value of 14 is just 14. Now we find the magnitude of both of these. Now notice that they're the same. We know that it's parallel, and so parallel lines are not going to have an angle between them, but I want to continue to go through this just to kind of prove that to you, that this should also work out. Okay, so if we have the, what am I trying to say? Magnitude for both of these is going to be the same because they're the same number. So -3 squared plus 1 squared plus -2 squared, all square rooted. 9 plus 1 plus 4, 9, 10, 11, 12, 13, 14. So we have square root of 14. So square root of 14 times square root of 14, that's just going to be 14 over 14, which is 1. So now if we just take the inverse cosine of both sides, we get inverse cosine of 1, which is equal to theta. And if we use a calculator, we can see that the inverse cosine of 1 is 0 degrees. So that's another way to prove that two lines are parallel, is to use this formula and see that we get 0 degrees between them. Okay, find the measure of the angle between the lines 2x plus y equals 5 and 3x minus 2y equals 8. Okay? So if we put this in y equals mx plus b form, we can see that the slope, or the gradient, is equal to -2 over 1. And if we do the same thing here, and the slope is 3/2 on this one. So if we change both of those into a vector, which is going to be x, y, we're going to get 1, -2. Because remember, rise is like change in y, run is change in x, and so the bottom is actually the x value. So it feels like we flip it upside down, but we're not really. Now this is our b1, and then our b2 is going to be 2, 3. Okay, we don't need anything else. We just need those two vectors. And remember, we have b1 dot b2, absolute value, b1 magnitude, b2 magnitude. Okay, so we multiply like terms, we get 2, multiply like terms, -6, and so overall that's -4. We take the absolute value of that, so the top is a 4. And then we take the magnitude of each of these, so 1 squared plus -2 squared, 1 plus 4, so we get square root of 5. Over here we have 2 squared plus 3 squared, so that's 4 plus 9, which is 13. Okay, now this is equal to cosine theta, and so we just need to take the inverse cosine of both sides and multiply those together. We get that. Go to the calculator, do the inverse cosine, 4 divided by square root 65. We get 60.3. Okay, if you need additional help, please come to Math Lab. Until then, calculator.